We know that when there's nothing in the way, light tends to just spread out from its source and travel in roughly straight lines. So each piece of light travels in a roughly straight line. So light coming from my face, the light's going out in all directions, but some of the light is going straight from my face to the camera. And that's why you can see an image of me, because the light's not getting all mixed up on the way. Well, what happens when it hits an object? Well, there's only a few things that can happen. It can be transmitted, for example, like the air. So the air between my face and the camera is basically transparent to light, and so the light will just go straight through. And remember that when light transmits through matter, it actually slows down a little bit. So the speed that it goes at is the speed of the vacuum divided by some number called the refractive index. So technically the speed up here, the 3 by 10 to the 8 meters per second, is in vacuum. And we've already discussed the fact that if light comes in at an angle to a boundary between two materials where the refractive index changes and therefore the speed changes, then that's got to change direction of the light. In this diagram, we're describing the direction that the light takes as the form of a ray like that. And this is often called the ray model of light. Which is not to say that light travels in narrow beams called rays, just that you can represent the direction that the light's going as a ray, and that's a really good model for working out all sorts of things, including the way lenses work and mirrors and so forth. And so we have these light rays describing the direction of the light. We talk about the direction of the light with respect to this gray line. This gray line here is called the normal to the surface. So here's the surface along here, and the line that's at right angles to the surface we call the normal to the surface. And then these angles just tell us the direction compared to that normal. And the first one is often called the angle of incidence because it's the angle at which the light is incident to the surface. And then when it goes through, this is often called the angle of refraction.